What if a simple transport aircraft could suddenly become a strategic bomber, enhancing military flexibility without extensive modifications or costs? This revolutionary approach is not just a concept, but a reality known as Rapid Dragon. A system that stands out for its simplicity and effectiveness. The pallets containing the missiles are loaded into the aircraft's cargo hold like any regular load. Once in flight, the pallets are deployed. The missiles reorient downward, ready to be launched towards their targets. How does this innovative system redefine military strategy? Let's find out. The development of this new system began in early 2020 through a collaborative effort between the U.S. Air Force and Lockheed Martin. The goal was to create a versatile and cost-effective solution to enhance the strike capabilities of transport aircraft. The initial phase focused on conceptual design and feasibility studies to assess the practicality of deploying cruise missiles from unmodified cargo aircraft. By mid-2020, the project moved into the prototyping stage, during which the first prototypes of the palletized weapon system were created. The Rapid Dragon's ability to transition from concept to successful execution within just 2 years underscores its strategic importance and the agility of its development team. The project also exemplifies effective collaboration between various entities to advance military technology. Initially driven by the U.S. Air Force and Lockheed Martin, the project also involves other significant partners, such as Raytheon and the Air Force Research Laboratory, AFRL. Lockheed Martin has been instrumental in the engineering and development of the palletized munition system, leveraging its expertise in aerospace and defense technologies. Raytheon, known for its advanced missile systems, has provided crucial support in developing and integrating the cruise missiles used in the system. The AFRL has played a pivotal role in research and testing, ensuring that the system meets the operational requirements and standards of the U.S. Air Force. Just a quick moment before we unveil the rest. If you're new here, consider subscribing to this channel. Stay up to date and never miss out on the latest insights. But let's now see what a Rapid Dragon is exactly and how it works. The system is a disposable, stackable parachute-dropped weapon module designed to deliver flying ordnance, primarily using the AGM-158 Joint Air-to-Surface Standoff Missile Extended Range, or JASSM-ER. This missile is known for its precision and effectiveness, capable of striking targets from a significant distance. With a range of approximately 575 miles, the JASSM-ER allows aircraft to launch attacks from beyond the reach of most enemy defenses. This long range is crucial for penetrating well-defended airspace, enabling the missile to avoid detection and interception by enemy radar systems. One of the key features of the JASSM-ER is its stealthy design. The missile has a low observable profile, reducing its radar cross-section and making it difficult for enemy defenses to track and target. Additionally, it is equipped with advanced guidance systems, including an inertial navigation system and a GPS, which ensure high accuracy even in contested environments. The missile's payload includes a 1,000-pound WDU-42B penetrator and blast fragmentation warhead, capable of effectively destroying hardened targets. The configuration of the pallets used in the Rapid Dragon system is highly versatile, allowing them to be adapted for various missions. Each pallet can hold a number of missiles, ranging from 4 to as many as 45, depending on the mission requirements and the type of aircraft being used. This modular approach means that the same basic system can be used to equip different types of transport planes, such as the C-130 and C-17, without significant modifications. When loaded onto an aircraft, the pallets are securely fastened in the cargo hold. Upon reaching the designated drop zone, the pallets are airdropped from the rear of the plane. As they descend, the pallets reorient themselves to position the missiles for launch. This automated reorientation is critical for ensuring that the missiles are correctly aligned and ready to be fired upon release. This innovative approach transforms ordinary cargo planes into formidable platforms capable of delivering significant firepower. Several tests have been conducted to validate the capabilities and effectiveness of the Rapid Dragon system. One of the most notable tests occurred in December 2021. During this test, the system demonstrated its ability to update targeting data mid-flight, showcasing its flexibility and precision. An MC-130J aircraft was used to deploy the Rapid Dragon pallets, which contained AGM-158 JASSM-ER missiles. As the aircraft flew over the Gulf of Mexico, new targeting data was transmitted to the missiles in real time. This capability is crucial for modern warfare, where targets can change rapidly, and adaptability is key. The demonstration included the deployment of a 4-cell Rapid Dragon pallet. 3 cells contained inert mass simulants, while the 4th housed a live missile. Upon release from the aircraft, the pallet stabilized under parachutes before the missiles were sequentially deployed. The live missile ignited its engine, performed a pull-up maneuver, and accurately hit its designated target. This test proved that the system could safely and effectively launch missiles, even under dynamic conditions. Further testing continued into 2022, with the system being integrated into different types of aircraft, including the C-17. These tests aim to validate the system's adaptability across various platforms, ensuring that it could be deployed from multiple types of transport planes without extensive modifications. The results from these tests have been overwhelmingly positive. They confirmed that the Rapid Dragon system can deploy missiles in a safe and coordinated manner. The automated reorientation and deployment process worked flawlessly, ensuring that the missiles were correctly aligned and ready for launch. The use of inert mass simulants alongside live missiles demonstrated the system's capability to manage multiple payloads, ensuring that each missile could be released without interfering with others. Extra demonstrations outside the US have also been conducted. For example, in November 2022, at the Andøya Space Test Range in Norway, the Rapid Dragon system was used in a live demonstration involving multiple allied nations. Additionally, in 2023, the U.S. Air Force conducted successful tests in the Indo-Pacific region during the Mobility Guardian exercise. These tests highlighted the system's operational flexibility and potential to enhance the strategic capabilities of allied forces. The concept of using transport aircraft to launch missiles is not new and has been explored by the U.S. military for several decades. One notable example dates back to the 1970s, when the U.S. Air Force considered the Cruise Missile Carrier Aircraft (CMCA) project. This initiative proposed converting Boeing 747-200 airliners into missile carriers capable of deploying 50 to 100 AGM-86 air-launched cruise missiles. The rationale was to leverage the large payload capacity and global range of commercial airliners to enhance strategic strike capabilities. Although the CMCA project was not implemented due to budgetary concerns impacting other military programs, it laid the groundwork for future innovations in airborne missile deployment. In more recent history, transport aircraft have been used in combat situations to deliver heavy munitions. During the Gulf War in 1991, the U.S. Air Force employed C-130 and C-141 transport planes to drop palletized bombs. Additionally, in the early 2000s, the Massive Ordnance Air Blast (MOAB) bomb, one of the most powerful non-nuclear weapons in the U.S. arsenal, was developed for deployment from C-130 aircraft. Known colloquially as the mother of all bombs, this weapon demonstrated the capability of transport aircraft to deliver massive explosive payloads effectively. The development of the Rapid Dragon system is a continuation of this strategic vision. The system offers several strategic advantages, particularly in terms of flexibility and cost efficiency. One of the main benefits is the ability to use existing transport aircraft, such as the C-130J and C-17, as temporary bombers. This capability eliminates the need for extensive modifications to the aircraft, making the system highly cost-effective. Since these planes can be quickly outfitted with the palletized munitions and then reverted to their original transport roles, operational costs are kept low. Furthermore, no special crew training is required, as the aircrew can use their standard procedures to deploy the munitions. In addition to cost savings, the Rapid Dragon system enhances operational flexibility. Traditional bombers require dedicated infrastructure and maintenance, whereas transport planes are already widely used and maintained within the military. By leveraging these existing resources, the U.S. Air Force can expand its strategic bombing capabilities without incurring the high costs associated with developing and maintaining a fleet of dedicated bombers. Another critical advantage is the ability of the C-130J and C-17 aircraft to operate from unprepared runways. These transport planes are designed to take off and land on shorter and less developed airstrips, such as those found in remote or austere locations. This capability significantly increases operational flexibility, allowing the Air Force to launch and recover aircraft from a wider range of locations. For example, while a traditional bomber like the B-52 requires a long paved runway. A C-130J can operate from a dirt or gravel strip as short as 3,000 feet. This ability to use improvised airfields means that Rapid Dragon-equipped aircraft can be deployed closer to the front lines, reducing response times and increasing the element of surprise. The use of these versatile transport planes also means that military operations are less predictable. Enemies may expect strikes to come from known bomber bases, but the deployment of cruise missiles from transport planes operating out of unconventional airfields adds an element of unpredictability. This unpredictability can complicate enemy defenses and enhance the effectiveness of strategic operations. The Rapid Dragon system is set to undergo significant enhancements as part of its future development plans. One of the primary goals is to expand its capabilities by integrating a broader range of munitions. The U.S. Air Force is exploring the inclusion of Joint Direct Attack Munition Extended Range Bombs, JDAM-ER for short, Quick Strike ER mines, and ADM-160 MALD, Miniature Air Launch Decoy, into the Rapid Dragon system. Each of these munitions offers unique strategic advantages that can further enhance the system's versatility and effectiveness. JDAM-ER bombs are designed to convert unguided bombs into precision-guided munitions, extending their range and improving accuracy. By integrating JDAM-ER into the Rapid Dragon, the U.S. Air Force can conduct precise strikes over longer distances, thereby increasing the operational reach of their transport aircraft. Quick Strike ER mines, on the other hand, are intended for naval operations, providing the capability to deploy mines from the air, which can be used to disrupt enemy shipping lanes and protect friendly maritime assets. ADM-160 MALD decoys are designed to confuse and overwhelm enemy air defenses by mimicking the radar signatures of various aircraft, thereby increasing the survivability of the actual attack aircraft and enhancing the overall effectiveness of the mission. In addition to expanding the types of munitions, there is also a focus on improving the system's overall performance and adaptability. This includes refining the deployment mechanisms to ensure even greater reliability and precision during airdrops, as well as enhancing the communication systems to allow for real-time updates and coordination during missions. As the system continues to evolve, the potential impact on modern warfare is profound. Rapid Dragon not only extends the reach and effectiveness of air-launched munitions, but also enhances the strategic capabilities of the U.S. Air Force and its allies, promising a future where flexibility and rapid response are paramount.